In my house, there are two kinds of switches. One's used for low power devices like your TVs or mobile chargers or your laptops and everything. And the other one for the high power devices like your air conditioners or your refrigerators, your geysers and things like that. I'm pretty sure the same thing exists in your house as well. So the question that I always had is, why do we have two different kinds of plugs? Why can't we attach high power devices over here? It's advised not to do that, but why? Well, to answer this, we need to see the complete picture of how all these sockets are connected together. What is the kind of circuit that we have in our house, which looks somewhat like this. Whoa, that looks very complicated. So you know what we'll do? We'll start from what we already know and then build up from there. Okay, so we've seen that for each plug point, there will be 3 wires coming in. So 2 wires come directly from the mains. One is the live wire. Another one is called the neutral wire. I'm not gonna write that because it's gonna get crowded, as you've seen. And the voltage difference between them is about 220 volts in India. And of course, we have one more wire, which is a safety wire, which is called the ground or the earth wire. This wire carries any current that is leaking off from devices due to any faults, ensuring that we don't get any shock. So ideally, it's not supposed to carry any current. And we've talked about this in previous videos, so if you need more details, feel free to check that out. But the thing is, in our houses, we don't have just one plug point, we have many plug points and many devices. And all of them will have these wires coming out of them. And somehow all these must be connected together in some kind of a circuit. So the first question we want to try and answer is, what kind of connection do you think we'll be having? And again, to answer this, we can start thinking from what we have already seen. We have already seen 2 kinds of circuit connections that we can have. We can have a series connection and we can have a parallel connection. So, what do you think is the kind of connection in our houses? Do you think it's a series or parallel? Or do you think it's a mix? Some are connected in series and some would be in parallel. Why don't you pause the video and just give this a thought? All right, if you have given it some thought, let's see. Let's start by exploring the series connection. The series is when you connect them end to end, right? Now, one immediate problem you can see over here when 2 plugs are, let's say, connected in series is that if you were to close one of this switch, let's say I put my mobile to charge over here and I close one of that switch, no current will flow over here. Why? Because this switch is open. See, this is one single wire. If you want the current to flow in this wire, then both the switches need to be closed. That means you need to switch on both these plug points in order for the current to flow. So either both will run or none of them will run. That's how series works, which means that's very inconvenient, right? I mean, I don't know about you, but I don't think I want my devices to work that way. I want them to be independent of each other. Does that make sense? And so if you consider that in mind, series is completely out of the option. So we cannot have any devices coming in series. So what does that leave us with? That leaves us with parallel connection. So the way we can connect plug points to make them independent of each other is we connect them parallel across each other such that each of the plug points are connected across the same points, the live wire and the neutral wire. So if you do it this way, notice now I can close this switch and the current will run through that because this is one independent circuit. It's independent of these plug points and those switches. So parallel is how all the circuits are connected in our houses. And of course, they would have their own grounds as well. It's also super important. And by the way, if you're looking at this, you're wondering what this curve means. It basically, denotes that the ground and the live are not connected to each other. It's just a way of showing that they are independent wires. It shows that one wire is going above the other. That's it. All right. So this now might make you wonder, does that mean every single plug point in your house and all the fans and all the devices get exactly the same voltage? Yes, that's right. Every single plug point will get the same voltage. That's the defining feature, right? And how much is that voltage? As we said, it's about 220 volt, which is pretty high. And that's what makes these things dangerous. And this might make you ask another question. Well, does every single device require 220 volt? What about your phone chargers? Do they need 220 volt? Well, no. In such cases, you know what you will see inside those inside those adapters, you will see small devices called transformers that can reduce the voltage if needed. All right, you'll learn about them in higher grades and everything. Don't worry about them, okay? The point is every single device, every single plug point gives you 220 volts. But not always. Ta ta ta. That's right. You don't always get 220 volts because there can be fluctuations. You might know about this. There can be, say, lightning strikes or short circuits or overloading, things that we'll learn about in future videos, of course. But because of all of these things, voltages need not stay the same. Sometimes you'll end up getting low voltage, in which case your light bulbs and your tube lights will glow a little bit less. Your fans will be working a little slower, which is a minor inconvenience, not a big deal. But what if sometimes you get a high voltage? That's also possible due to fluctuations. You might get, say, I don't know, maybe 1,000 volt, which is totally possible. What happens then? Well, then your devices will start drawing more currents if they are connected. And then your devices can blow up. That's one thing that can happen. But there are more dangerous things that can happen. You might know that if as the amount of current starts running through the wire, as that amount increases, the wire starts getting more and more heated up. And if this wire is not designed to handle that current, then that heating effect can actually melt the insulation, exposing the live wires, exposing these wires, and they can go and touch other wires and cause all sorts of problems. Another thing that can happen is if the heat is too much, it can even catch fire. That's just the worst. Which means to safeguard ourselves, let me just get back to normal. To safeguard ourselves from this dangerous high voltage fluctuations, we need to somehow make sure that if the current exceeds a particular value, then the circuit disconnects somehow. How do we do that? Well, you might already know about that. That's where a fuse comes in. So this is what we call a fuse. So what exactly is a fuse? So what exactly is this fuse? Well, a basic fuse is just a wire which has the ability to get heated up much quicker than the rest of the wires. So as the current starts increasing in value, the fuse wire starts getting heated up very quickly, and after a point, it's the fuse wire that immediately melts. And as a result, the contact breaks, and this ensures that the entire, the domestic circuit, the circuit in your house is disconnected from the mains. And that's how it ensures safety. And how do we build a wire like that? Well, what are the properties of this wire if you're wondering? Well, a couple of properties, important properties would be, one, it needs to have a very high resistance compared to the rest of the wires. Why? Because a high resistance ensures more heating effect. We have seen that before, right? As the current flows through any object, if it has more resistance, it will have more heating. So that ensures more heating. And to ensure that it melts quickly, it will have low melting point. So it also needs to have low melting point. So with these two features, a fuse wire can be built to protect our circuits. And so now you may be wondering, what's the maximum current this fuse wire can handle? Well, that depends upon different kinds of fuse. You can manufacture different kinds of fuses, but the ones that, the low power circuits that we have in our houses, those fuses can usually handle up to 5 amps of current. If the current exceeds 5 amperes, that fuse will melt. So the idea is in this normal circuit, like where your fans and tube lights are connected, the current drawn is very low. That means if the total current exceeds 5 amperes, that means something unusual is happening, and that's why this is designed that way. So this is what we would call a 5 amp circuit. And of course, you may be wondering, hey, I don't see these fuses in my house today. Where are they? Well, today they have been replaced by these new devices called circuit breakers. They work on a very similar principle, but over here they don't melt. You don't have to change the wire every time a fuse blows up. They just disconnect automatically. Okay, a little bit more advanced, but the idea is the same. So let's not get into that. So perfect, right? We have the fuse to protect us from high voltages. We have the ground wires to protect us from some faults. Everything is fine, but there's one problem. What if I want to run my air conditioner and geysers and refrigerators and other high power devices? What will happen if I connect all of them and switch on all of them? Then together they will definitely try to draw more than 5 amps of current, and the fuse will blow up for no reason, right? This was not unusual. It's just that high power devices can't run on this particular circuit, which only limits to 5 amperes. So what do we do? What do you think we should do? Well, it's for that reason we will have a separate circuit for those high power devices. So that's why those plug points, which are responsible for, which provide power to high power devices, will have a separate circuit. So it'll also have its own live wire. It'll also have its own neutral wire. It'll have its own fuse. And we can now guess that this fuse can handle higher amount of current, right? So it turns out that this high power circuits usually handle about 15 amps of current. So anything above 15 amperes, then that fuse will melt. So in our houses, we will have two independent circuits. One is 5 amps and another one is 15 amps. And of course, they should also have their own ground. Ground is definitely required. So all these grounds will be connected together. So will there be only two circuits or can there be more such circuits? The answer is you can have many more circuits, each one with their own fuse. It all depends upon where you're staying, how big the house is, or whether it's a factory or things like that. But usually they'll be having one 5 ampere circuit and one 15 ampere circuit. So how do we put this all together? I mean, there are only two wires, one live and one neutral coming to the house. So how do we distribute it into different circuits? So the basic idea is we connect them all together. So let me show you. So we connect all the neutral wires together and we connect all the live wires together after the fuse. And we put this in a box, which is called the distribution box, right? Because it's distributing the incoming wires into different circuits. So let me just write that. This is called the distribution box. Distribution box. And then this wire can now go out of your house and then you connect to that electric pole. But your electric company needs to bill you, right? They need to know how much electricity you're using. It's for that reason, it doesn't directly go, it goes through an electric meter. Again, something you may have seen. And the basic idea behind this meter is, at least the old ones, is that, there would be a disk, and depending upon how much current you take, how much current you're drawing, the disk will keep on rotating, and then they will just calculate the total number of rotations the disk has turned. And that's how they calculate how much electricity you've used. And so from there, the wires will get connected to the mains through another fuse. You might be asking, why another fuse? Why not? Fuse is a safety device, right? So it doesn't hurt to have two levels of safety. This will again be a higher level fuse, higher amperage fuse. So definitely more fuses at more levels means more safety. And there we have it. This is how our domestic circuit looks like. Hopefully this looks a little less complicated now. All right, so let's put it all together and see if we can recall some important things. So my first question to you is, can you recall what kind of circuits that do we have usually in our house? Series or parallel or mixed circuits? Second question is, why do we even use a fuse? Can you explain that to a friend? And what are the two important properties that the fuse wire must have? Can you recall that? And also why? And lastly, using these two, can you now explain why we need to maintain two separate circuits, one for low power devices and one for high power devices? If you have difficulty answering any of these questions, feel free to go back and check the video out again. And I'll leave you with one bonus question. Why is the fuse always connected to live wires? Why can't we have a fuse with a neutral wire? Even there, when the fuse melts, the circuit breaks, right? So why is it always connected to live wires? Think about this.